A warm welcome to everyone. I am Snehaaigali, student of Sri Venkateswara College of Engineering, Bangalore. Well, guys, today I am up with this interesting subject called as mathematics. In that, we'll be studying about statistical inference in mathematics. First up, let us see what is statistical inference. Statistical inference is a process of making conclusions or predictions about a population based on some data. It involves using statistical methods to draw inferences about a population from a sample while considering uncertainty and variability. Statistical inference plays a crucial role in decision making, research, and understanding relationships in various fields of study. Next up is population and sample. A population refers to entire group of individuals or objects of interest in a study. A sample is a subset of the population that is selected to represent the entire population. Statistical inference allows us to make statements about the population based on the information obtained from the sample. Next up is estimation. Estimation, it is a process of making or estimating unknown population parameters using sample data. Point estimation involves using a single value, that is point estimate, to approximate the population parameter. Interval estimation provides a range of values, that is confidence interval, in which the population parameter is likely to fall. Next up, we have hypothesis testing. So now what is hypothesis testing? It is a statistical method used to make decisions or draw conclusions about a population based on some sample data. It involves formulating a null hypothesis, that is H0, or we can even call as H0, and an alternative hypothesis, that is H1, to test the validity of a claim. Next point is statistical tests are performed to determine if there is enough evidence to reject the null hypothesis in favor of the alternative hypothesis. Now next we have two types of error, that is type 1 error and type 2 error. So let us see first what is type 1 error. Type 1 error occurs when the null hypothesis is rejected, but it is actually true. Type 2 error occurs when the null hypothesis is not rejected. That means it is accepted, but it is actually false. The significance level, that is alpha, determines the probability of making type 1 error, while the power of test represents the probability of correctly rejecting a false null hypothesis. That is likely to be a type 2 error. Next up, we have confidence intervals. Confidence intervals provide a range of values within which the population parameter is likely to lie. The confidence level represents the proportion of confidence intervals that would contain the true population parameter if the estimation process is represented or repeated multiple times. A wider confidence interval indicates greater uncertainty, while a narrower interval indicates greater precision. Next up is central limit theorem. So what does central limit theorem states? The central limit theorem states that the sampling distribution of the mean or the sample statistics approaches a normal distribution as the sample size increases, regardless of the shape of the population distribution. This theorem provides the foundation for many statistical inference methods, as it allows us to make assumptions about the population based on sample means. Next up, we have sampling distributions. Sampling distributions shows the distribution of sample statistics. Example, we can consider as mean or proportion across multiple samples of same size from the population. The shape of the sampling distribution is influenced by population distribution, sample size, and sampling method. The sampling distribution of the mean tends to be approximately normal, even if the population distribution is not. Now, next up, let us go through the p-values. The p-values is a measure of the strength of evidence against a null hypothesis. It represents the probability of obtaining a test statistic as extreme as or more extreme than the observed value, assuming the null hypothesis is true. If the p-value is small, that is, if it is below the significance level, it provides evidence to reject the null hypothesis in favor of alternative hypothesis. Next up is confidence versus significance. What are its differences? Confidence intervals and hypothesis test are two complementary approaches to the statistical inference. Confidence interval provide a range of possible values for the population parameter, while the hypothesis test help determine if a specific value is possible. Confidence intervals focus on estimation, while hypothesis tests focus on testing specific claims. So next up is its assumptions and limitations. Statistical inference methods often rely on certain assumptions about the data and the sampling process. Violation of these assumptions can affect the validity of inference made. It is important to understand that the assumptions and the limitations of the statistic inference methods used to ensure accurate and reliable results. So what are its practical applications now? Where all we can use statistical inference? Now we have 3 points over here. That is, it is widely used in various fields which include medicinal field, social science, finance, and engineering, of course. It helps researchers draw meaningful conclusions from sample data and make informed decisions. Its examples include clinical trials, opinion polls, quality control in manufacturing, and risk analysis. So now we have come to the conclusion, that is, statistical inference is a fundamental concept in mathematics that allows us to make inferences about populations based on sample data. It involves estimation, hypothesis testing, confidence intervals, and consideration of assumptions. By understanding statistic inference, we can make more informed decisions and draw meaningful conclusions from the data. Well, guys, that was all about our statistical inference. I hope this might help you guys. Thank you so much for watching.